So, what will we handle during this course? Major topics. Well, you know the basics of these layered models: application, transport, network layer, link layer, physical layers, intermediate systems. So we'll go along starting with the application layer as a motivation. So why do we do this? What are different applications? What are the problems there? And if you know the problems, we'll then go deep down into the physical layer, discuss this and say, okay, what is the physical layer today? How can we transfer a single bit, go up into the data link layer, the MAC layer, covering the network layer, going into the details of IPv4, v6 and the problems there, the new developments. Also in the transport layer, we will handle not only the classical TCP/IP, what about QUIC? What are the pros and cons of such new protocols, DCCP, etc.? What are new trends there? If you have cloud computing and some other information-centric networking, new paradigms compared to the classical internet. So overall, the internet, as we see it, is a very prominent example of networking. It's not the only network, it's the prominent network. But why should you know more about this? Well, you know how to cross a street, and you know what happens with cars and etc. And if you use the internet, you should know also how the data flows. So what's going on there? Because the internet has a huge impact and many more changes will come. So one goal of the course is make you an informed citizen. So what are the powers behind the internet? What drives the changes? So we also hint at different areas where you may dig more into. At the end of the course, although this is a master level course, you will not know everything to immediately start in a research department knowing all the tiny details, but at least you should know where the challenges are and where you can start digging into, and then you have to read many, many more things. Just think of one of the communication system, even a simple, let's say a wireless LAN system. If you look up the standard today, thousands of pages. Mobile communication systems, tens of thousands of pages. No one can teach you this. But I will give you basically this little red thread through this jungle of standards, of protocols, of ideas, of concepts. So, what should you know at the end of the course? You should know definitely how networks are organized in general. So, how do we organize them? Maybe there are better ways of organizing, but okay, that's the way it is. You should also know what the internet is, or at least could be, and you see, okay, that was the original idea, and now due to market forces, developments, etc., it looks a bit different. You should understand how wired networks work. We have a separate course in mobile communications for the wireless world. You should know much more about protocols, why we use them, where we use them, and where maybe it's not a good idea to have layers. You should know how basic services and applications work and how, for example, the videos get to where you need them. You should understand how operators really operate real big networks, not just the lab networks, but the big ones. How, for example, browsers cooperate with servers, how to secure your networks, what are security issues, and then the nightmare starts. Yes, I know. You will learn many, many more acronyms. What is an MTU and NAT and NTP and UDP and TDMA and SMTP and SNMP and P2P and QUIC and this and that. Okay, some of them you will know at the end of the course, and some of them you will at least be able to sort them into the right layer. And what was this reverse address resolution stuff, and what is the difference between CIDR and this and that, and you'll learn this. Okay, just to give you an overview, this course is here on master level, shown here in a yellow. Telematics, where we discuss all these protocols, the internet, etc., in a bit more advanced style. We also offer the other courses, communication networks, operating systems on bachelor level, some other computer architecture, etc. And after this computer networks course, you can easily participate in mobile communications in our different labs and software project, distributed system, reliable systems, etc., seminars, courses, lab work, etc. So, be aware. There's a basic requirement. You should know the basics of networking. You don't have to remember all the tiny little details, but you already know the reference model, what a reference model is. You know basic networking, you know what a socket is. You've done your socket programming, you know what TCP/IP is. Not all the tiny little details, but you should know the basics. If not, this is the wrong course. First attend the basic computer network course and then come back. Or if you want to participate here, please go through videos of the basic computer networking course, then come back. You will see some overlap, yes, but we will really briefly touch the basics and then we go to the advanced topics. Otherwise, without knowing the basics, you will have problems following this course. Okay, having said that, related fields. We are not alone on this planet, so yes, we are in the center. Everyone is in the center. So telematics, data communication, computer networks. But sure, this has to do with algorithms. This has to do with operating systems, databases, software engineering. Within algorithms, you know, distributed algorithms. Without communications, how do you want to distribute anything? So distributed algorithms need communications. Sure. Operating systems, we also distribute them. Think of grid computing. Then we have grid operating systems, somehow distributing the big jobs. We distribute database and we do software engineering for distributed systems. This is all handled by computer science. Sure, we also need some communication engineering. We don't really handle this too much here. This is more for the engineers than really to design fibers, cables, antenna systems, how to do the modulations, how to design the chipsets for this. We handle here more the computer science part. You're not happy with videos alone, plus the discussions in the classroom? There's literature. There's a lot of literature. So, there's not a single textbook specific to the course, but if you like the top-down approach, I really recommend Computer Networking, Kuros Ross. This is a book going top-down, 8th edition right now, so this is a very good book covering all these advanced aspects. Also, the basics are covered by Tannenbaum, Weatherall, Computer Networks, also a well-known book. And then there are some more books touching more the math part. But in the end, you have to look into the standards. For example, IETF or IEEE, they cover the major standards for the internet and for the underlying layers like IEEE handling all the Ethernet standards, wireless LAN standards, etc., the lower layers, and IETF, all the internet stuff. Okay, so you have books, you have videos, we have the discussions, and sure, there are many more videos and lectures out there. Please go ahead, have a look at them. So in the end, what is this? Okay. You'd say, oh, it's a triangle, so that's kindergarten stuff. So, but think of it, why is this a triangle? Isn't this just 3 vertices? Is this straight lines? So what is the concept behind it? Have you ever seen a real triangle in your whole life? Have a closer look. Come even closer to this video. Is this really a triangle? No, I doubt. Why not? Have a closer look, even closer. Don't you see the pixels? No, this is not really a triangle. Can you draw a triangle? No, not really. Well, you can come close, but can you have a straight line in real life? Really? Not even with a laser. The laser is spanned by gravitation. So yeah, everybody would say it's a triangle, that's kindergarten. So even though no one has ever seen a triangle in real life, everyone would say this is a triangle. How can this happen? Well, it's abstraction and your imagination. So this comes from your brain and from examples, and all these examples have a common concept of a triangle. So the real triangle only exists in your brain, nowhere else. So this is an old ancient Greek lesson, yeah. So basically, what is behind this story? You have to make the effort to understand the concept. So I can show you examples of a concept, but the abstraction must happen on your side. So you have to make the effort to reprogram your brain to see a triangle. That happens with little kids. So they come on this planet without any concepts of triangles. So we have to reprogram them. Okay, it's called teaching, but it's basically a reprogramming of the brain. So in structures, like me, I can show you examples, but until you work at it, it's not going to go inside your brain. So you need to make an effort on your side to internalize it. So your goal is that your brain is different after the class compared to before you got in. So that's the idea. So let's try reformatting your brain to when you were born, grasp the concept of a triangle. Okay, we don't try this with a triangle, so don't delete the concept of triangle now in your brain. But for the other concepts, I try to teach you. You have to program your brain. Okay, what else did we learn? So one is to understand this concept. The next thing is from atoms to bits. Well, before the internet, how can we send information? So we'll come back to what is information, but it was sent basically by atoms. So we sent books, we sent letters. So we sent expensive physical objects. So to transmit information, we need atoms, we need some matter. So a book. Okay, after the internet, or communication in general, so I know communication is older than the internet, but most of the information is sent as bits. So bits, that's no matter. There's no atom connected to a bit. Bits, they go through a network. That's much, much cheaper. So basically, books. Do we need books anymore? Classical newspaper, music on discs, videos on tapes, etc. So, okay. So that's a tremendous change. So we don't need the atoms anymore. I know signals are transmitted using electromagnetic waves, etc. What is an electromagnetic wave? And so on. But in the end, we don't have to transfer matter anymore, which is good. So much faster, much cheaper. Third side of the story, I show you a copy of a story that's old. Well, so we all copied Socrates, Plato, thousands of years ago, who originally drew this triangle in the sand and was asking, what is this, to a student. And basically had the same idea behind this. So the digital world copies, and every one of you can take these slides and copy them. Please go ahead. So why not? Without losing anything. And that's new. In former times, copying something, sometimes you lost maybe information, lost certain quality. Today, we don't lose anything. We copy without any loss. So what does this mean to society? How does this change? Well, sometimes brilliant idea. Think of Wikipedia. Everyone can copy the knowledge stored there and use them no matter where you live, as long as you have access to the internet. So, most important here is you are responsible for your brain. Don't stop thinking. Some questions. Recap the basics of networking. You must be familiar with the basic concepts, must be familiar from a high-level perspective, TCP/IP. I will come back to all the tiny details. Yes, you should know what are client servers, etc. So see the bachelor level networking course. So ask yourself, do you know the difference between UDP and TCP? Do you remember the layers of physical layers, link layer, networking layer, transport layer, applications, etc., etc.? And the motivation behind it, you know roughly what protocols, packets, headers, etc. are. If yes, fine, great. Check organizations like IETF, IEEE to get a better understanding who's doing what. So what is the IETF responsible for? What is covered by IEEE? Who's working on the application layers? So get a better feeling of what's going on there. And think of yourself. Most important part, what type of learner are you? Are you type of, okay, exam next week, binge watching, last minute panic? It will not work. Believe me, it will not work. If you like reading books, go ahead. If you like watching videos, please do so. If you like to come into lectures, you're welcome. We will discuss. Please prepare yourself for the lecture, then we can discuss the interesting things. And the lecture is more a discussion. It's not just consuming slides. This is what we have the videos for. So please prepare yourself, then we can have interesting discussions, go into some more details for some topics.